Hey everyone, Lazy Ben. Just get this social media stuff sorted first, and we'll begin. All right then. Just turn the music down a bit. So, where were we? So yesterday, we put in the fast travel effect. Let's just check that code out, because I remember that code being pretty crazy. It's a bit of a mouthful, that code. Game dev, game state. Oh, we're already in game state. So where did we do that code? Tick NPCs, tick patrol. Yeah, so this is like, this section of code's quite, it's lambdas in lambdas in lambdas. It works though. Okay. So I think all we really forgot to do here is I think we should probably just mark the patrol pause reason is fast travel out now, because we're just moving out of the effect. And then at the end of the frame, so we play the effect, get the duration. At the end of the frame, now we could maybe do all of this at the end of the frame. Could put that up there. No, it's fine like that. Alright, let's just test. Let's just run it. Let's put this around here, really. There we go. So, we've got two situations now. We can fast travel, and NPCs can fast travel using this transporter. And then if we wait a second, we should see Jenny beam in, because we modified a patrol to come into this room. And she chooses to go to fast travel to this room rather than just walk there. Here she comes. Right. So, one of the things I did want to work on, actually, before we move on to the world map, is I want to get this to cast shadows in the world. Ooh, that was well, that must have been Jenny heading off. Yeah, so that looked like it was. That was just Jenny. That was Jenny's. Yeah. It looked like the effect was open, then shut, and then open again, but that was just Jenny's effect. Okay. Right, so we want it to cast shadows. So if we go back, shouldn't have really taken out this test case here. We had a test case here that made the effect go all the time. Let's just do that. Let's put it back in. Let's put it back in. So auto position equals get NPC position hero value r vec2. Canvas is get game canvas, and then do is 1, and ET is made up of 2 floats. So not 5, so auto ET equals T over T max, and then all we do is we check that doesn't go over 1, and then we'll just go T plus equals DT. If T is greater than T max, T equals 0, so we just recycle T. Alright, so let's just put that effect back in. So this will just permanently render this effect all the time. Constantly leaning in. Give me a sec to sort this camera. Right, that's good. Alright, cool. Just pull these. Move this again. Alright, so that effect just basically follows the player around now. Just going in and out. Now it doesn't cast any shadows, so it's all, yeah, it's been rendered in front. Oh yeah, I know what's going on there. We're actually overriding the Z. So, we want it to cast shadows in the world. So let's check it does go behind. There we go. So, you know, we wanted to cast, if we do this, we want it to cast shadows and God rays. So let's use this room as the room we're going to test it in. So I believe we have another lighting effect, and that does cast shadows and God rays. See that God ray and that rock there? See, it's casting shadows. The rock behind the effect. The rock is in front of the effect, and it's casting God rays. It's a bit hard to see, but it definitely is. So we're just basically now going to copy the code from that effect where we were casting it, the grid effect, to this effect so it can cast shadows. We also want to come in on the planting room. So that's game.config. So the first room is the planting room. Let's just check that you can actually launch into that room. Alright, good. Right, so let's have a look at how the the grid effect, it's called the laser grid effect, casts shadows. So it's a begin, draw shadows, end, begin planting laser. And it just uses what is called a light token. So if we place tokens into the render queue to say, have a begin and an end, I think. Is that how it works? Token first. Yeah, begin and an end. Token first, token last. The first and the last. And it just says, in between these two tokens, we want to draw shadows. So, we need to do that. So begin planting laser, end planting laser. So they return light tokens. So we're going to go light token, begin fast travel beam. And I believe we can just pass in all these arguments. And then end fast travel beam. And then draw fast travel beam. So that's, we will call it when we don't want shadows. And then we will call these when we do want shadows. Okay. So let's implement them. So what I'll populate, well, let's just close the rest of the windows, and then I'll open the duplicate window here, and we'll just stick that down here. You can see most of it on stream. And begin planting laser. So we'll just go through what this does. So basically the same. So it's auto token equals create light token, and we need the box. So the box is the area on screen. Everything that's in that box casts a shadow, I think. So we work it out here. So let's just okay, so this get world wrecked might not return, because it might not have a camera in it. So I need to make sure actually before we do that what space this box is in. Planting laser, we're looking at the wrong one here. It's is it planting laser? No, I think it is. So what is the box? The laser bounds. And the laser bounds are in world space. Okay. That is dependent on the world wrecked. So I think what we have to do is we have to say auto world wrecked equals get world wrecked value R just a blank rectangle. So the world rect might have no area in it. So I think we have to make this an optref. Okay, we'll make it optref. It's a shame that the API is slightly different to the others, but it has to be, I think. And then we can just say optref light token. And then at the end, we'll just return token. Okay. We've got the bounds. So with those bounds, we're going to create the light token. So token equals create light token. Bounds. And then we do the range. Then we build the mesh. And then we append the current. We append to the current light token range.vertices. And then we add the draw item. And that's it. Let's check that builds. Okay, good. So does create light token make it? Yeah, it sets it to be the current light token. Great. Okay, so and that's basic. It's the same call as the others. Don't need to change that. Right then. So let's go back to the effect controller. So in the laser grid effect, we'll just copy this and then we'll go to the fast travel beam effect. We'll just say if 0, else, and if. So we can swap between the two. So I believe that the token is canvas dot begin fast travel beam. Swap this to be the active one. We don't have the level. We've got end light there. Ah, end light. Just say end fast travel beam. We'll keep it. So we don't have the level. So the bounds as well. We need to know the bounds. and the Z. Oh, let's ban this person, ban this bot. So we need the bounds. So we have the token, the Z. So the Z is this. The bounds is where we want. I think this is actually the box that we need to. Anything in this box is going to cast shadows. So does the light token contain any box? It does contain a viewport. Depends what that viewport is. Light bounds. That's just a square. That just inflates the box. It's center of the box and inflates it quite big. So I think we can just use the glow shadow viewport. We'll try that. Just the laser bounds. So token. It's optional. If token glow shadow viewport token Z game state. It's just called state. Okay, see if that builds. Nope. Level, we don't have level. How do we get the level? State.get current level. If level. Do that. Right. So let's just see what this looks like. See if this just works. That build. Okie dokie. So what does this look like? See if this works. See if this just draws shadows. It does not. Okay. Right, so we're not even... Ah, no, I know why it doesn't draw shadows. We've done it in the wrong place. And you do it on our test case, which is in game state. Okay, let's just say this is temporary so I don't forget and leave it in. Level. So everywhere we say state, we don't need it. All right. Yeah, it wasn't drawing shadows there because we were That's not where the code was. It's not where the execution was. The execution was in this test case here, so we need to do it here. Still not drawing shadows there. Okay. So what is the view part? The view part is in screen space. That's probably why. So what that means is we should probably pass in the actual bounds instead of just the position and the width. So that's const rect bounds. Whoops. So it's bounds color T direction Z. And then we don't need to work it out. So we can say if bounds.area and camera index, we just do this. And then this comes now outside the function. Let's check that builds. World rect. So I think the aspect is just bounds dot height divided by bounds dot width. And then here we need to work out the bounds. So width is 10. Not 1, 10. 10. Position, width, bounds. This is canvas. Get world rect. And then we pass in the bounds. All right, so if we're passing in the bounds, we can get away with it. Yeah, we'll keep it optional, it's fine. All right, let's check that builds. Good. And then we also need to do it here now. Whoops. Okay. All right then. So let's see if we have shadows. Bounds now would be in world space, which I think is what we needed. Oh. Yeah, we need to actually use it. Bounds. So I'm thinking maybe these bounds need to be, the bounds for the shadows might need to be a little bit bigger. I mean, we'll see. Let's see how it looks. Okay, still no shadows. We get our light token. We draw the shadows. Getting any shadows drawn in. Yep. And then we end it. Token first, token last. So we should be drawing one shadow, which is that rock. Okay, so let's debug this. Let's see what we can get. We need to make sure it's called next draw. So we need to rebuild the lights, rebuild the shadows all the time. How do we do that? Where is it? Shall we put in something where we could force a rebuild of light maps and shadow maps and stuff? Reflection, refraction. So this is glow shadow and floor shadow, so this is it. So maybe just put all true. And that'll rebuild them every frame. We need to rebuild it so it will cache. It will cache if nothing changes in terms of the layout of the level and the position of everything. It caches it to the next frame, so it doesn't have to render the shadow maps every frame. But we need to make sure it does, because we're gonna pix this to see what is actually being rendered. Pix is just a program that I use to debug GPU stuff. Alright. So let's see. Game canvas. Process game canvas. Draw shadow batches. It's here actually. Right then. So there's a rock. Where's the shadow bias in the rock actually? Look then. There are all the accessed resources. There's only that texture. Should have drawn the shadow by now. Right, what I want to do is actually go into the editor and put this light move this light here. So the shadow bias is alright there. It does look a bit, it is a bit flickery. That's probably because we're drawing them every frame. That seems dodgy to me. Okay. Let's get rid of that true. Yeah, that's better. So we've got shadows on the rocks. The bias looks good. Okay, so let's just save that. And then let's rebuild the level with the light in the new place. Check that's actually working. So it is. So let's pick that again. And we'll see what the difference is between the one that's working and the one that's not. Oops. Okay. So we've got draw shadow batches. So we just filter by draw for a second. It's definitely drawing it in the wrong place. And it's not actually even drawing the light. This one is using a cache. floor shadow target. So it should look like that. Okay. It's quite clearly then these viewports are in the wrong place. Alright. So let's have a quick look at so we're just saying that the bounds of the effect is this bounds here. Is that actually right? Laser bounds comes from the middle of the laser bounds. So this bounds here is what it's testing. Are you inside this bound if you are cast a shadow? I don't think that's right, is it? I think it needs to be the player bounds. So it needs to be the position. So it's rect. Position. Inflate. We'll say inflate by 5. We use a different bounds. And this could also be wrong. Yeah. Okay, I think that's wrong as well. So we're going to say we need 2 bounds then. So let's go back to the original one. And this can be the light bounds. So we should be able to undo this. Yeah, this is all coming back to me now. So I think what we do is we do this. So it's not optional. And then the light token. Create light token, light bounds. All right. And that goes to position 10, and then we need a light bounds. Yeah. And that goes in there, and that goes in there. So we make the light bound around the player. I don't actually think the player is the right place to make it around though. I think it needs to be the bottom of the what's the problem here? It needs to be the bottom of the beam rather than the player position. The bottom of the beam is this though. Yeah, no, that is the bottom of the beam. That's fine. This isn't the player position. This is the position of the beam. Let me get it from the player position at the start of the effect. So that's fine. That's good. Alright, so let's just go back. And then we're just going to say auto light bounds equals rect position inflate by 5. So that is the light bounds. And then that is the light bounds. Obviously these tokens now are just straight up references. So is it a reference or is it a they are references. Fine. Is it copy? All right then. Same here. Width undeclared identifier. Okay. We don't need to use these bounds anymore. All the world rect. Don't do that here either. That's nice. Very good. Alright, so let's see what happens now. What's up? I tried. How's it going? Got any questions? Just ask. Still no shadows though. Yeah, that's right. Custom engine. Working on a sci-fi gardening game. We're only like 6 weeks in though, so it's right at the very beginning. I'm just working on a fast travel effect. This laser beam's a fast travel effect. Where the player like shoots up into the sky. I'm just trying to get it to cast shadows. So this light here casts shadow of this rock. And this laser beam doesn't. I'm just trying to figure out why. Oh great, yeah. What are you working on? Oh yeah, brilliant, yeah. Yeah, I Am GUI is great. Say it's a good place to start, I would say. I Am GUI. You get a lot of good stuff on the screen straight away. How are you finding C++? Let's leave that off. Not as bad as you thought, coming from Python. Yeah, it's quite different to Python. Yeah, no, white space doesn't really mean anything in C++. You mean indentation, is that what you mean? Yeah, because Python you have to like put colons everywhere and tabs. Yeah, you could write an entire game and not actually press return on the keyboard. Yeah, it doesn't. That's right. No white space matters really. Apart from inside strings and stuff. Yeah, you need to get used to looking at C++ because it's quite, I think it's quite difficult to look at compared to something like Python. Especially when you start doing things like templates. It can be hard to read. But it's a very powerful language though. You can build anything. Yeah. Yeah, it's all quite confusing at the start. You'll get used to it though. The way I imagine it is you've got two CPP files and headers can connect them. That's the way that I imagine it. So you've got like a header and then everything that uses that header branches off it, including the implementation of the header. Yeah, no headers in Python, is there? I remember. Yeah, I mean, you technically don't need multiple C++ files for anything. I think people just... It's nice when you start building bigger things to break the code up. Really, just so you don't end up with tons and tons of code in one file. But there are libraries out there that are just one CPP file. I think I Am GUI is just one or two files, isn't it? Okay, yeah. Yeah. Things like languages like Python is a lot of stuff that happens and it seems like magic. Which I personally, I don't like. I like to know why everything is happening the way it is. That's what C++ is like, yeah, takes the magic away. In a good way, though. You get to understand how absolutely everything works. Yeah, brill. I think Python's a good It's a good kind of language to learn, just to get the idea of what a language is, and then move to something like C or C++ to learn how the computers work with a programming language. OpenGL, yeah. I'd say if you do like 3 or 4 months maybe of C++, a little bit every day. If you do like half an hour a day for a few months, OpenGL start making sense. If you're wanting to do games and graphics, it's a good place to start OpenGL. So when you feel comfortable enough with the actual syntax of C++, try something out like OpenGL, and then you actually be able to start drawing things. And then build up from there. It's really fun though. I think learning a new language is fun. As long as you don't push yourself too hard every day, because it is tiring. And then once you know C++, you'll probably be able to program any language you want after that. Yeah, great, yeah. That's a good goal. And do all that in C++. I mean, Linux itself has got a lot of C++ in it. Or is it C? I can't remember. I think it's probably both. All right. So I'm obviously not remembering why this doesn't, how to do shadows. Let's just pix this again. Let's just. So pix is the program I use to look at stuff on the GPU. So let's have a look. I want to look for anything that has shadow in it. So we draw the ground and we draw the light. So it probably should have drawn it. So that's the floor shadow target there. So let's have a look at the wireframe for that. So that's what that looks like. So that is... Okay. There's the dude. Ah. So that's the effect. Okay, we're way past the drawing of it now. I need to go through this code and remember how it works. Oops. Okay, so that's the light bounds. Two matrices. How does the lightning... what was it? Round strike. Strike effect. So it's a pause, inflate 10. Submesh bounds. Translates to position. So there we've got the light token. So the box. Okay, so there we've got the light token is actually the bounds of the thing casting the light. So let's have a look. So that's this bounds. Okay, so let's put this over here. And let's just set the light bounds to be that. I think actually it has, we're adding draw items, so I think it actually has to be at the top. That'll be fine. I think it will be fine. Because it's sorted, isn't it? Okay. Can't assign to it anyway because it's constant. All right, let's just change this. Okay, that means that needs to go back to be going in Octref. Yeah, that's right, yeah. So yeah, we break... One of the key skills to learning programming is working out how to break your problem down. And then you can... Each bit of the problem could be a separate function. Definitely. And that's language independent, no matter what language you're using. You have to learn how to think like a coder, you know. So token equals create light token bounds. That unfortunately means so what I'm going to do is, where are we? Fast travel beam. I'm going to turn this off because we're changing this around all the time. I'm just going to work on it here instead. That means that is optional. Let's see what happens now. Still nothing. All right, see you in a bit. So we're inflating by the box width there. So maybe we should be inflating by the max of the box width, box height, maybe. Oops. We'll figure this out. I mean, that's a massive area. I wonder if it's that it's because it's an oblong shape. Because like they cast shadows from the center of the center of where they're casting light from, and because the light beam is an oblong shape and it's casting the shadow and it's missing it. We'll see. All right, so let's go back into here and we'll just say or true again. So we're building them all the time. So that breaks those guys. Doing that. Now I think what we actually do to make the shadow dirty for this particular one, we have to append to current light token just something. So we'll do a new ID, which would be different every single frame, and that'll make sure that it gets built every frame, because that will change the ID of the light token every frame. Then we don't need this or true here. Okay, that means you can properly debug it. Alright, so let's pick that again. So my expectation is that it's casting the light from here and it's like not reaching it. Because it's so tall. Okay. So it's making the shadow map. So that's the God rays. That's the shadow map. And it's making them on the floor shadow target. Glow shadow target 1. Shadow target 1. It's a big 1080 by 1080. Alright, I'm going to take a 2-minute break, make up a cup of coffee, and we'll solve this. Happy coding. Happy coding. Right, fresh cup of coffee. So we called this the floor target, floor shadow target. So let's just follow this through. Right then. So those are enormous viewports there. 2160 by 2159. They are big. Maybe bigger than I want. Oh, yeah, I've got a bit of a kind of cold thing coming on, unfortunately. I just went away to Butlins with my kid and my wife, and that's like 10,000 young children, and I came back with a cold, unsurprisingly. Alright. I mean, that is the one. Okay, so we'll go back here. We create a glow shadow target. 1, 1. Okay. And then draw floor shadow batch. Imaging world. Okay. Floor shadow. And then radial floor shadow is the pipeline state. Lighting. Radial blur floor shadow. Oops. Got glow shadow. Floor shadow. Right, so we draw the shadow. And then I'm going to draw a UV in world. XY UV in world. So this is the floor we're going to draw next. Then the light. Then the shadow. Apply floor shadow. Okay, so this is the floor. And then the rig. I must have been stood in front of that light last time. Right, we'll draw the rig. And then the fast travel beam. And then the image, so this image, I'm assuming is this. No. Alright, we need to start this again because this is not synced. Let's go again. We need to stand at a proper location that we can go back to. So we're going to stand, we'll go... Yeah, we'll go here. So we're definitely behind the light. Okay. Definitely behind the light there. Okay. We'll run the game. All right. Where is it? Yeah. All right then. So let's have a look at the drawers. Okay. So we've built this shadow target up. So we draw the floor, then the rig. Okay, so this is drawing the lights, drawing the shadows. We're drawing the shadow batches. We draw another set of shadow batches. Okay, so this is the floor. This is the rig. And then the fast travel beam. The rig. Fast travel beam. And then this is the light. Yep. And then the light texture. So that's calling flush lights there. I reckon that's what we need to do. So we're calling flush lights. We need to call flush lights before Let's call flush lights with the fast travel beam. See what that does. Hopefully that's it. Because we've drawn all of the texture maps, but we've not actually sent them down to the shader. Well, that didn't work either. We need to set. That's the glow. That's fine. Ooh, yeah, no, actually, we do need to apply the glow. I'm beginning to remember how this works now. So it needs to be 2 passes. Yeah, that's to get the God rays, it needs to be 2 passes. Lighting, apply, floor shadow. Draw XYUV floor shadow batching world. Okay. So let's go back to the fast travel laser. So we flush the lights. There's nothing to flush, it says here. That's fine. And we're running an XYUV batch again. So let's go back to here. So that's going to be that light. And then we're straight into grass after that. So we missed out the lighting glow. Why are we missing out the lighting glow? Let's go back a bit. Let's do it again. Okay. There we go. Light. lighting. Then the next one is where we apply the shadow. Light floor shadow world. So we're not... Yeah, we're not actually... Where do we actually put that in? Here. Begin light internal. Yeah, okay. Alright, I think I kind of get this now. So, in planting laser does do a glow. So we need to add 2 more draw calls. That's what the problem is. I haven't done this for a while, for like 6-7 months. So I'm forgetting how it works. Okay. Light glow simple. And then the planting laser. Right. Now this might be quite heavy duty. Okay. Because these render targets are so big. So begin fast travel beam. Let's just make it a second window. There it is. So this is just position. Bounds. Bounds.width. What I might do, I mean that's huge, that makes a huge kind of render target that. I'll just do that. Alright, let's see what happens now. Um, so that bounds.width, it's not big enough. It has to be bounds.height. That makes a huge... That makes a huge... You can see the glows there. God, it's big. Alright, so we're going to change this. This is going to be position inflate by 10. Right, there it is. So we're glowing over the top now of the rock. How long have I been coding for? A long time. Started when I was like 13, and I'm 39 now. So, you know, 25 years, something like that. Making game engines for like 20 years as a hobby. Well, I'm stuck on a particularly... Well, it's not a bug really, I just can't remember how the lighting system works. So I'm trying to familiarise myself. So I'm not really making much headway at the moment. Oh yeah, Copilot, yeah. I did try that. I couldn't use it. It changed the way... changed the way I code too much, I think. People say if you stick with it, and you learn to use it, it's really, really good and increases productivity. I found that I was reading too much. It was suggesting stuff. I spent too much time reading code it suggested and not enough time writing it. And I like to write code. It's a hobby. It's a pleasure thing. So I'm not really interested in maximum productivity. I just want to create stuff. Yeah, Copilot must be pretty good for learning, I imagine. Suggesting things. Yeah, C++ is big. The language is big. So it's, you know, like, it's difficult to kind of take it all in. Like if you're finding C++ too big, you could go to C, which is very small in comparison, but it still has stuff like pointers in it, you know, so you'll still learn all that memory management. But you know, I would suggest just sticking with it. Might take a few months. Okay. So let's just pix that now. Now we've got this glow. We've got this thing called token first as well. Ah, right. So that must be the texture index for the glow. I'm just looking at the shader and I can't see us applying any. Oh, here we go. Alright, so we actually do need... I thought this was far more automatic than it actually is. We need to actually subtract the shadow in the shader. When we do that here, alright, let's just pix it and see where it is. If it's really not automatic, maybe we should just abandon it. Okay, so the glow stuff isn't even appearing really. So the let's put this back in. Not the minutes, the maximum. All right. I was just saying C++ is a really big language, so it takes quite a long time to absorb everything. If you're finding yourself having a really struggling with absorbing all the syntax, you could try out C, because it's still very powerful and it still has all the things in like pointers, and you can do OpenGL and do all that, but it's much smaller syntax. And then when you've done C for a couple of months, move on to C++. So what I want to know is, oh yeah, you'll get onto pointers for sure. It's the core of the language, really. Timbo, thanks for the follow. Oh, thanks. It's part of the fast travel system. I'll show you it. So, let me just turn this off. So you can go to these fast travel bays, and then this UI is not implemented really. This is going to be the world map, and there's going to be a list of discovered locations, and then you click on it and you can just fast travel to it, and it uses that cool effect as like a teleportation thing. Then the NPCs can do it as well, which is cool. So they can like go over to the fast travel when they're doing their daily patrols, and then use the teleporter. That's what I implemented yesterday. If you've got any questions, Timbo, just let me know. See, there we go. This and the NPCs come and used it. What I'm particularly working on at the moment is I'm just looking at like trying to refresh how the shadows work. So the NPC, yeah, you give the NPCs patrols. I'll show you. So this is the editor for the game, and then you can define patrols. This is a simple one that I was just using to test the fast travel system. So each patrol, so you can have multiple patrols, right? And they all have time of day. So that's not 23, so that's all day. So but you can have different patrols for different times of the day. And you can make them go to different places and do different things. And then these are just travel nodes. So this trigger, it travel to this trigger, and the trigger's there in the world. And then after you've travelled to that trigger, travel to this trigger. So what it would do is the NPC used to just walk all the way to it, and this is like a doorway, and it's like there's like 10 rooms between the start and the destination of the patrol. And then I put in fast travel, and then I made it so the NPCs can use the fast travel. Yeah, it's like it's not as powerful as Blueprints, but it's a full node. Like there's, I get node based for all the dialogue and everything. Timber link lists. Oh yeah, great. Yeah, spend a lot of time learning how all that stuff works. So you can, like dialogue uses it. So this is all the NPC's dialogue. So you can say a bunch of things to you, and they're all like trees. So I can, wherever she is, find out where she is. Oops. So I can like walk up to her and, I've got a quest to trigger when I walk through one of these pink squares, so you can talk to her and stuff, and she like marks a new planet on the radar. And the radar's to do with the crafting system. Oh yeah. C++ is great. You can build anything on a computer. Absolutely anything. As long as it can work on a computer, you can do anything. Yeah, so she can mark up planets. So there's a radar which is to do with crafting. So you go to one of the rooms and there's a radar in there, and you can tune the radar. and listen for messages. Oh, hang on, we had some shadows there. Look, there they are. They're just in the wrong place. Yeah, man. I need to figure out what's going on. So all these rooms are like prototype rooms for gameplay. So the game's right at the beginning. I've only been making it 6 weeks. So I'm just making a bunch of rooms, and each room's got different gameplay in it. So this is a radar. So that was the location that the NPC gave. So you click on it, and then you put these data cards in the radar, and then you like find the right channel, and then when it locks, it goes yellow, and the data cards start charging up. So that's like meant to be receiving messages from the planet, charging these data cards. And then you go through to the next room, and you can download the data into these blueprints that you get given throughout the game for like crafting. So if you want like a cannonball, well, they're all unlocked at the moment. But you can download data into them to unlock them. That's just currently wasting all the data. And then once you have these blueprints, you can craft with them. To make apple seeds and all sorts of things. It's all very early days at the moment. It's going to be a sci-fi game, but you're like the gardener on an enormous space station. And you're like, you know, make supply runs to asteroids to gather resources and over the planets and come back and plant them in your garden. And then the crew of the space station will admire your gardens. But right now I'm just trying to figure out how this shadow works. So they are there, look. It is casting shadows on something. I mean, I have completely forgotten how this works. Plan on making procedural environments, predetermined resource spots and hubs. Yeah, maybe. You mean like the asteroids and things? I haven't thought too much about that. I think what I have thought about was you're going to have bases, so you'll be able to take your ship to the bases, and then maybe around the base, so the base will be like neutral zone, and then around the base, so you'll be able to go out of the base and find rocks and things to break. So Sven's meant to be a droid, like a mining droid, and you can break these rocks apart and get iron ore and stuff. So there's gonna be like rocks around and, you know, other resources. And that the placement of the rocks and stuff may be procedural. I'm not sure. Obviously, you have to make the shadow disappear. Oh, there we go. We got something there. Okay, so it's the wrong size. So can we do it there? Why can't we do it with the... begin planting laser. So let's just not do this shadow in the planting laser. Let's see what we have. Maybe because it's not square. All right. There we go. It's pretty... So that's it, that's it. Got shadow now. Not quite as good. That one's like good. Must be to do with the size. My only concern with doing this is that this render target's massive to do this. I think. Like, I wonder if we could just fake it. Maybe we should. Not have it based on the beam. But just put a light, like a fake light there. This render target is like 2K by 2K. Okay. Where do we want it to come from? Let's do rect position plus vec2. We'll just fake it for a second. Put it up by like 5. And we'll inflate it by 10. Okay, so yeah, we have light bounds. We'll use this light bounds. See it cast in there. So it's not casting. It's not casting as big as I want. So we're going to stick that, well, we'll leave it like that. So let's pix that and see what it looks like. As far as I can see, there's no... It's not drawing over the top. Draw number 76. Hmm. Light bounds over 2. Just down a bit. Let's go into another room. Okay, it's probably a bit easier to see it with So let's just paint one of these in. Easy to see it with some boxes. So let's have a look at the light. How does the light do it? Build light cloud in world. Glozy. Passed in. Okay. T times width. Okay. So it looks like here we are creating the box out of all the vertices. And then the width. So it's just a bounding box. Okay. So let's just draw the light bounds. Pixels to world. So let's draw the light bounds. See where we're actually drawing. So that's plenty big enough. Okay. So we create a light token. It should be the same, which is twice as big as the light bounds. It's pretty big. The light bounds are twice as big as this input box. Okay, so that can potentially be 5 then. Set the current light token. So we create a camera. Okay, a couple of cameras. And we just build a quad in world. Width is 10. That's kind of the wrong width. This width. All right. Is that working? Don't think so. Looks like it's working there a little bit. It's just very dim. Okay. PS main glow. Just return 1 here. No. No. So what shader am I using? Simple light glow. Okay. Right, I'm going to take a quick break and then we're going to debug this. Alright, so we've found in the code where the lighting glow happens. So let's just mess about with this. Okay, so I can immediately see a problem, I think. It's the wrong size. Alright. So this has to be this size. I might actually have to go through and tidy this up because I might have to. Let me start this mic out. Turn it off. There we go. Keep making itself loose, which is annoying. Okay, that should sound a bit better. All right. Yeah, so it was the wrong size. Might need to neaten this up because... There we go. Might need to neaten this up because I completely forgot how it worked. Which is not great. Which would mean a token should have in it this. I should call it the glow bounds or the light bounds, whatever. So we're gonna be rect light bounds. And then we're just gonna say token dot light bounds is that. And then this can be token dot light bounds. And then we're gonna have to change. We're gonna change everywhere else where that happens. So let's put this shader back. And this light bounds here is position plus an offset. So we don't need to pass in this light bounds either. That'll simple it up a bit. A banana. In game state, it's just the position inflated by 5. Which is fine. Let's let this build. Might set up a some video I can use for my YouTube channel. Rest it against these bananas. Do set up a time lapse. I'll record for 10 minutes. All right. Whoops. So I want to neaten all this up because I completely forgot how it works. And that's rubbish because it wastes a lot of time. I want something that I can copy and that is easy, works automatically. The problem is all these different bounding boxes. Got this one, and then I needed to put one in here as well, and it's like, well, what is what? So I need to just basically derive all the bounding boxes from one bit of data. Right, we'll check this works, and if this works, and we'll neaten it up a bit. We'll make those changes. There we go. Cast a shadow now. That's all I wanted. Right. So we're going to remove these light bounds. The light bounds is just basically rect position inflate by 5. And then we'll remove light bounds from here. So the API is the same. Position, width, color, T, direction, Z, yeah. Which is even better. And then this token has light bounds in it. And because we're creating out of the position, it doesn't need to be optional anymore. Which is even better. None of the other ones had to be optional. Okay. I'm just gonna get rid of that. I'm rid of that. Token's not optional, which is great. It's a reference though. This is token light bounds. Okay. There we go, and it draws in shadows. So we also want, so the shadows, we want that, so the effect fades out, and we want the shadows to fade out as well. And that, so if T goes from 0 to 1, we want it to go, so we want, auto glow T equals BM, how do we want to do this? One minus T times T. T goes from naught, -1 to +1. That means it goes from naught. So -1 to +1. So that would be naught down to 0. And then up to 1 again. So it'd be naught. I think it's that. But T has to go. T goes from that, and then this is T2. And then auto glow bounds equals token dot light bounds dot scale my glow T. Then we're just gonna say if glow bounds dot area, do that. That should fade it in and out. Maybe. Is that what's happening? It seems a little bit so a quick see what glow T is. So rather than actually scaling the glow bounds, we'll set the colors alpha. And we just times it. No. Should be able to though. Our colour is operator times. Could add that in. All right. Okay. See what that looks like. So I want to fade the shadow in and out. Turn this time lapse off. Let this build. Alright. Unfortunately, we changed colour, so it takes quite a long time to rebuild after you've changed the colour because it's used everywhere. And once we've done this, we'll just go through and we'll change where we're creating light tokens for the rest of the renderer to use the light bounds inside of the light token rather than just calculating it. Then once that's done, we're going to draw a line under it and move on to what I actually wanted to work on today, which was world map stuff. So it fades out, and fades in again. Yeah, so the shadow fades in and fades out. Okay. Right, so let's just port this over to the effect. Fast travel beam effect. Then we will delete all this. And we also need to go into the editor and place something in the fast travel room to cast a shadow. So we will put in I want to show the triggers. So we'll put in this bookshelf thing. All right. We'll see if we can cast a shadow. We'll see. All right, let's go to it. Fast travel. Well, I didn't see it. Let's go back again. Can we hide colliders? No, hide triggers. Oh, it is there. It is there. Watch here, look, you can see the light bleeding through. Great. Let's just move it closer. It's great. Okay. You can see the light bleed through there. So if you watch Jenny, don't want to talk to you. Oh, I don't want to talk to you. Print the screen here. I don't have print screen on this keyboard. Anyway, it's working. All right, great. So now let's go back to wherever. Let's change wherever we create light token. So this is the planting laser, and this is token. Light bounds. All right. So let's check the planting laser still works after we do this. Still cast shadows. Yep. All right. And whoever's calling this. This probably needs to be token dot light bounds. Cool. So this... Ooh. Inflate T times width. I think what I might do is leave that the way it is because it's modifying it. Alright, cool. So that is good. We cast in shadows. We finally got it to work. So a quick look at the notes. NPC should be able to fast travel too. We did that. Fast travel should be optional in the editor. Do we want to do that now, or do we want to start with the world map code? Yeah, I think we're gonna do these in order. So fast travel for NPCs should be optional in the editor. That means modifying the patrol editor. So a route patrol node. We'll probably put it in here. Patrol route. That would be a good place to put it in the editor. Then we need to work out in the default world generator. We need to work out how we get the pathfinding to ignore fast travel locations. So it means like a warp connector needs a type, I think. And then in the A star, when we're actually doing it, so we need to basically ignore locations that ignore warp connectors that are fast travel locations. Oops. A star. Star game location. So in the world where we generate the path, we do path 2. We need to do an ignore. Then we need to pass the ignore in there. So this path 2 is used in the patrol here. So we have patrol state. Patrol state could have in it whether we want to ignore or not. Okay. So I could see we could do that. It's a bit of a change. Okay. So the patrol route, we want U32 Abul. Do we want to flag this? No, we won't flag it yet. Cool. Ignore fast travel stations. Alright, so let's start putting this in the editor. And the patrol editor, tick left panel for route node. We're going to go canvas, draw checkbox. Ignore fast travel. Stations. Route dot ignore fast travel stations. All right. Got route wrong somewhere. There. Yeah, it's melt your brain for a while. Keep at it though, it's very rewarding. If you need any help, just let me know. I'll help you out. Right, so we've changed the editor. Yeah, brilliant. Programming for me is like, it's one of the most creative endeavors you can do. It's just like painting or writing a book. Gives you that same creative feeling. It's really good. So we need to make sure, so these patrol routes, are they actually serialized into game patrols? They are, so that's fine. To compiled, it just whacks it straight into storage. That's great. Okay. Yeah, have a good gaming sesh. Nice to meet you. Alright, so let's have a look at Jenny's patrols. And we should have in it now. Ooh, it's cut it off. Ignore fast travel stations. It's because it's too long. Ignore fast travel. So what we're going to do is we're going to tick this once it's rebuilt. No. It cannot handle a change of string literal. Oh well. Okay. Where were we? So we're in the patrol. It's planting droids patrol. Ignore fast travel. Save this. And then we are going to go into game patrols. And then is there an initialize? There is, but nothing's in there. Let's just take that out then. Alright. So let's just see if we can find that this value is true now that we are ignoring it. I need to make a note actually, because I did notice it's not really a bug, but we've got well, it is a bug. Can still download data into unlocked blueprints. Need to actually make that not happen. All right. So patrol state. Patrol ID. So this is Jenny 1. Route. Ignore fast travel stations. True. Good. Okay. So how do we want to do this? It's the path to. So we might do flags here. Enum path to flags. Well, do it this way. Namespace E path to flags. Flags. Enum value. And then we're just gonna go ignore fast travel stations. And then we need to do enum flags. Enum flags value. That's how you do that. BM enum flags. Okay. Right. So path 2 now is going to take ePath2 flags value flags 0. Let's check that builds. We say 0 like that. No. Have to say none. ePath2 flags none. And then we're going to have the flags here as well. So we'll give that a size. And then here we need to forward declare that, and then we need to put it in the actual in here. And check that builds. And then we should probably do that. Does this include the world? It does. Nope, didn't like that. All right, so we can now in the world, when we're doing path 2, you can pass in the flags. Which we will use later. But in the game patrols now, we do this. We need to say, check this is the only way we use it. The only place we use it. Use it there. Draw quest objective. That's fine because all that is for the drawing quest objectives is a map thing, so we can always use fast travel. So we're going to say if patrol state, so we're going to go ePath2 flags value flags none. Then I'm going to say patrol state route, ignore fast travel stations, flags. We're going to R in ePath2 flags, ignore fast travel stations, and then we're going to pass that through. Alright, so let's check that works. Alright, while this is building, I'm going to take a 2-minute break and get a cup of coffee. Yeah, so we're going. All right. So flags, route, ignore fast travel is true. Let's path through that. A-star has doesn't have flags. So we need to actually set this to a default value. We cannot do that because we're forward declaring it. So we need to do this. Right, so I think that's fine. I think that worked. So now, in the A-star, we can use the flags. So it's get neighbors. World, get what from source. Get warps. So it's both of these as well. to destination. So get warp from source, current position to there. And everything else in the room. Get warp from source. So I think it's only here that we need to do it. So if warp so a warp in it now needs the warp kind. Which is unknown, room to room, fast travel station. And I'll put that in there. And this is kind is other dot kind and that. And then to serialize, it's just connector dot kind. And then in the world generator now, this is dot kind equals ewarp kind room to room, and this is dot kind equals ewarp kind fast travel station. And we need to rebuild the world now with all this new warp stuff in it. And now that means we can go if warp.kind equals ewarp kind fast travel stations and flags and path to flags ignore fast travel station continue. Means we can't add those nodes in. Okay, let's see if that works. So in that now, Jenny's patrol should not use the warp, use the fast travel stations. Unsure about here though. Get warp from source. So P current. P current should have been added in here first, I think. Maybe I have to check it. P current should have already been added here, and then it comes back in, which means it's not a fast travel station if we're ignoring them. All right. So where does she go? Yeah, it looks like she's not heading towards the fast travel station. She's going to go up here to this square. So she's taking the long way around. Awesome. Let's check it. Check she complete. I mean, she should complete. Looks like she's going to complete. Just mainly checking that she completes and she returns. She goes back. So that's when we change to the next patrol node. And we do a new path. Yeah, and she's going to go back. That's awesome. We can beat her by going fast traveling. Right, so now if we open a patrol up again, change it. We'll say, no, we don't want to ignore fast travel. We'll see if she takes the fast travel station this time. Awesome. So I think she's going to go and take it. I don't think we will want, in the game, we'll want all NPCs on all patrols to use fast travel. Great. Alright, I'm going to check all this stuff in. And then we will mark. We did this. Right, starts the world map code. UI with navigation, locations. UI with navigation, locations. Right, we'll do that. So, oops. Let's go to game config. And we'll just go into fast travel room. And what I mean by start the world map is we're not going to implement an entire world map. We're just going to implement this bit. And I'm not even concerned really with if it's geometrically correct to the game world or anything yet. That'll come when we start properly thinking about the world map. What I want to do is just create a scroll, like a draggable canvas that I can add locations to that we can click on. We've got an hour and a half left to do that. Because that's what I wanted to do today, but we've got like sidetracked with a bunch of other stuff. Okay, so that is in game menus, right? Fast travel menu. Draw world map canvas. So this is completely, it's only got one label in it at the moment. So we need a scrollable not a scrollable, a draggable canvas. Right. So in debug draw, we have draw world grid. Okay. And that gets the canvas from the debug overlay canvas. So what happens if we want to supply our own canvas? So that should go here. And that should just be draw world grid canvas. So we'll start off in the game menu by doing that, just drawing the world grid on. And then, I don't know, there isn't a camera attached to this canvas, so it probably won't work. But we'll see. It's probably going to be temporary. Where is it? Debug draw. Right, so let's see let's see if it actually draws anything. If it doesn't draw anything, it's because there's not a proper camera attached. It didn't draw anything, probably because there's not a camera attached. Camera, there's nothing in it. Right. So, how do we do that? How do we add a camera? Set camera state. Camera state. There's a lot of set camera states. Okay. So I think what that means is, flash over menu, we need a camera state, right? World map camera. And we'll just do, before we draw the world map canvas, well, do we want to, we'll do it in here for now. Canvas.set camera state, world map camera. And we'll see if we can draw it now. It might look a little weird because I think the default camera size is like 1080p, and obviously the grid, the world map, is smaller than that. No. Well, they're all correct. Oh, that's good. Add a camera index. Alright, so why isn't that showing anything? Because we haven't the scissor might be wrong, possibly. So let's see if we could get cut off by the scissor. Fast travel world map canvas. Oh look, it's there. It is there. Ah, it drew it. That red, there was meant to be a red line across there, but it's the same colour as the background. And then it drew over it. Yep. So because we're drawing these on int min. Okay, which means we need to supply the Z. And then we'll just say that this is int min. And then here, supply the Z as 0. So we do undeclared identifier. Oh, it's not Z32, it's S32. Here, where are we actually calling clear? The Z layer for background, which is actually 2. Right, okay. So this needs to be, we need to get the Z order. This Z has to be Z order, get Z, easy layer, quad. I believe that they're all drawn as quads. Yeah. Alright. That should do it. There it is. So we won't bother drawing the label world map. We're just going for something we can drag around. With the mouse. Okay. We're not drawing anything now we've stopped that title. So we need to do auto scissor equals canvas get renderer get remaining draw bounds, and then we need to do canvas dot add to bounds scissor dot height, and that returns a new scissor, which is the draw. Whoops. Which is the area we can draw on. There we go. Right, so we need to be able to drag this around. So I think begin by putting a input box, camera input ID equals canvas dot add input box. This is for the full scissor. I'm going to call this fast travel world map camera box. And then we're just going to say if canvas is hot, you can do canvas draw quad outline scissor 1 float color 1 Z Z order get Z easy lit quad. Right, so that should just detect that we've put the mouse over the world map. There we go. Then we're going to say if canvas is focused, camera input ID. I'm going to say if not canvas has drag. If we're not dragging the canvas, we'll do canvas.clear focus camera input ID. Otherwise, we're dragging the canvas. So the straightforward way to do this would be to go world map camera dot position plus equals canvas get world drag delta world space drag delta vector. Now that might not feel that good. We'll just test it. We might have to cache where we focus and then move from there. Might feel alright, I don't know. No, it won't work at all. World space drag delta vector. Alright, so what's going on there? Let's log line this. So it's either there's no delta vector. Oh, it's drag space. No, that's the wrong one. Drag delta vector. That's what I want. Alright. Oops. Let's try that again with the right function this time. If this works, we should be able to drag it around. There we go, it's backwards, but we can drag it around. No, we can't. It failed and then it worked and then it failed. It's working sometimes and then not. Oh, I know. It won't immediately have drag. That's why. So how do we do this? Could just say canvas.get window. Get input window. Left mouse button. Up. You could actually just tie it to the left mouse button. This just means extra code if we ever wanted to support any other input devices like a controller. Oh, it's not. It's not. It's if the left mouse button is up, we clear the focus. Else, we change the position. The delta felt alright. The other way to do it is when we store the position when the mouse goes down, and we move. We actually set the world map position rather than push it using the delta. Feels a bit slow. I mean, that's probably just because we're running at 60. So now we're running at 250. That isn't that bad. Don't feel too bad. So we probably want to make some space for some buttons down here because we want to like center on player location and stuff. All right, but we'll do that later. We'll do that later. Okay, so we won't draw this as red. We'll draw canvas.draw quad. Scissor. Float color. We'll draw it like I don't know, kind of a grey. Like, I don't know, 2222 22. Z order get Z easily layer quad. Well, say background. I don't actually know what colour the world grid lines are. Default grid color in the config file 424242. Okie dokie. Right, so this allows us to drag around the map. So what we kind of want is just some really high level code to add locations onto a map. And see there, it's kind of going off the end as well. So let's just do inflate it by 16. All right. Still not kind of. Still a problem there, isn't there? So I'm wondering if rather than pass in the canvas, we pass in the bounds. In world space. I think that might be better. So we'll do that. So this is just const rect world bounds. Whoops. Let me just do this. Do you need camera for anything else? Nope. And this is canvas.get world bounds. Get world rect. I think. Canvas.get camera.get world bounds. What does get world rect do? Pixels to world client bounds. So get camera, get world rect, get world bounds. Oh, maybe this scale as well. Yeah, so maybe we just pass in the camera as well. See if this has fixed it. Get rid of all these compile errors first. What's the problem? It doesn't know about camera. It needs a canvas as well. Right. Okay. So I'll put that in right here. Canvas. Canvas. Right. Okay, so it's not drawing it properly. What did I mess up there? Oh, because the scissor. Yeah. The scissor's not in world space. All right. Let's go back. Let's go back. So I think what we're going to have to do to fix that problem of it drawing over the top so you have these lines down here. It's strange why that's not scissoring out. It means that this scissor is not quite as high as it should be. Maybe we do scissor.xy 0. Let's try that. Okay, so we do scissor.width height plus equals scissor.xy, and then we'll set xy to be 0. Nope. We could just say scissor.height plus equals 8. That's a proper hack. Just wonder why that 8 is there. Anyway, that's going to be fine. Alright, so what we need now is some kind of world map controller where we can place points onto it. And we can place points onto it. So this is a new controller. So world map controller. This is where everything to do with the world map's gonna go. So we're just going to create a struct called world map location. I'm just going to say vec2 position and then an ID. Now we want to be able to add fast travel locations. So we maybe do something like enum class e world map location type. Unknown, and then fast travel station. Right. Type. So this is going to get a lot more complicated, but we'll keep it because it's going to, you know, everything in the world map is going to go here, but we'll just start really straightforward and we'll just manually add in an array of locations. And we'll do it in the constructor when we start the game. Oops. So locations equals so we're going to put, so in the fast travel controller we've got these stations, transporter room 1 and transporter room 2. So we'll add them in, right? So we're going to say, so we'll include the fast travel controller and we'll say what is it? ID type position. So we're just going to say, we're going to hard code the position for now. And we'll just say the ID is get fast travel station ID for transporter room 1. The type equals e-world map location type fast travel station. I'll say dot position. I'm just going to say it's going to be 1010 on the world map, right? Check that builds. Does not build. Static. It's not static. Alright. Check that builds. Right. And then the second location is going to for transporter room 2. And we'll put that in -10, -10. And then we want to get the locations. We'll span this for now. I don't think we're going to be ever messing with this, but maybe we will. And then what we might do is we might do something like W string view, get location name, and then that's going to be world map location. Be const for everything. And then we just want to go if location type is a fast travel station. We need to go if auto station equals get fast travel controller, get station. Don't have get station. Optref fast travel station. Get station U64 ID, and that just returns stations find D. Okay, if we can get the station location ID, then we return lock station kind. Lock not defined, so we need to include localization. It's not there. It's there. Alright, so we get the location name. Then in the game menu, we basically just want to we'll include the world map controller. We just want to go for, so we're going to auto world map controller. Oh, we need to be able to get the world map controller. Get world map controller. So we actually need to make one of these. So get world map controller, and for auto location in world map controller, get locations. I might call this map. I'm going to say if auto name equals map get name, get location name for the location. If there is a name, we'll draw it. Canvas, draw circle in world. The circle size we'll say, well, the center of the circle is location position. The radius, we'll say 0.25. Seg count, we'll just say 16. Color, float color, 0.10. Z order, get Z, easy layer. There isn't a circle. I think quad will be fine because I think it just uses all the same. RGB, X, Y, and world. We'll see if that all draws in one draw call. Alright, so that should just draw all the locations. And then we want canvas draw string. The font. So the font is going to be the canvas.get text font, I think. Maybe. And the font size is canvas.get font size. So we're going to draw the string. So the font is the font. Font size is font size. The text is the name. The color, we'll say float color, we'll say white. Black color, float color, black. Position is canvas.world to pixels location dot position, and Z is Z order get Z easy layer text. Let's see what this looks like. Oh, there's transporter room 2. There's transporter room 1. So 1010's quite a long way away. Let's make them 5-5. World map controller. Oh yeah, transporter room 1 and transporter room 2. Now, as you can see, they've got no geographical relevance at all to the game. That's going to have to come later. I need to build some kind of system that creates these maps. There's no point spending time on that until we kind of know exactly how the world's going to be laid out. So what I want to do next is we have to click on these. Got half an hour. Might be able to do this. Okay. So we're going to create an input box. So we need the bounds. Auto location bounds equals rect. Position, location position. Inflate by 0.25. And then we want to go auto box ID or location. Well, say box ID equals canvas dot add world input box location bounds name. I'm just going to say if canvas dot is hot box ID we'll do this up here. And then we're going to say canvas dot is hot box ID. We'll just draw it a different color. If it's not hot, see if we can highlight them with the mouse. Cool. All right, so if we click on it, if canvas is just focused, box ID, clear the focus away, and now we want to actually do this. So we're going to say so we need to distinguish fast travel regions from non-fast travel regions. So we're going to say if location type is eWorld map location type fast travel station. We only have fast travel stations at the moment. We know it's a fast travel station. So rather than get the name there, we're going to go auto station equals get fast travel controller, get station location ID. If not station, continue. So we've got the fast travel station. So this can be location, this can be station ID, this can be the localization of station find. So this S dot station kind. I believe it's okay to just pass a reference to the station through. And that can be station, and that can be station kind. All right. So we don't know about. Okay. So what's the problem here? Fast travel station kind. Actor ID, source station, dest station. So the source station is this station. So this is dest station. And this is destination kind. Okay, so that means or destination ID equals source state equals station, or destination equals station. So we don't want to display the station we're in. I mean, we kind of do, we just want to be able to click on it. Alright, let's see then. So there's no transporter room 1 anymore, because that's where we are. I'm going to go there. Fast travel to transporter room 2. And nothing happened. Why didn't anything happen there? Okay, that's screwed up. Don't want to do that. At least we didn't crash. Alright. Fast travel transporter room 2, yes. And there he goes. Awesome. Now obviously the world map isn't a real world map. We need to work on that. I don't know what else really we'd want in here until we worked on the world map properly. Probably want to draw the player. Yeah, I mean, maybe we do tomorrow. We spend a bit more time making it a real world map. We've got a lot of code for it already in here. This radar actually works for certain things. See, it has the NPC traveling around, and it also has quest markers. So if I start a quest and we track it, you get a white, and they really work. So maybe we do the world map to something similar. Right. Okay, I'm pretty tired today, so I think I'm going to end the stream. Done quite a lot though. Been at it since 9:30. We put in the basics of what I wanted to get today, which was to be able to fast travel using a world map. Interesting that is there. Well, I've got 25 minutes. I might just fix. And that is there because that's telling me that's the quest marker telling me where to go. Yeah. Oh, it's nice to know that that works with fast travel. Okay. Yeah, I've got 25 minutes, so I'm going to work on a bug. Which is this one. Can still download data into unlocked blueprints. So let's go to transport room 2. So there's nothing in the data cards, but if I do this, well, hang on, I need to get some data in the data cards. So if we go here, we put these in here, and we select a blueprint, you can see that button is still there, even though it's unlocked. So maybe we just put in here all the blueprints that we've not unlocked. Problem is if we do that, as soon as we lock it, it will disappear, which will be weird. Yeah, I think all we do now is we'll get this button. We'll disappear this button. So that is in game menus. You're already in. Data downloader menu. Untick. So which one is it? Not that one. Top canvas. Unlock blueprint. Appleseed blueprint. Blueprint state unlocked. So we're going to have to say if BP state equals unlocked let's do canvas draw label unlocked. Alright, that should fix that. We can't press that button if it's unlocked. We need to think about more about how we lay all that out, because there's going to be a lot of blueprints in the game probably, and if this is particularly about unlocking blueprints, we don't really want the locked ones, the unlocked ones there. Right, yeah. So it says unlocked now, which is good. So let's charge him. All right. So if we put them in, it says it's unlocked. So it says unlocked there as well, but that's actually probably going to be a description. So maybe we could add the recipe description in here. Because in the crafting bench, it puts the recipe in there. Okay, yeah, we might do that. Crafting bench menu, draw recipe canvas, draw crafting recipe. Right, so that's in the craft. That's in the crafting bench menu. So let's try and make this like bench. We need to know what bench we're at. Oh, that's only for the queuing though. So we can just Right, so this is 2 places. No. So I think what we're going to do is we're going to say e crafting bench kind bench is unknown, right? And if bench is not equal to unknown, we do that. Oh, no, I've done it in the wrong place. Try that again. Here, we want it. E crafting bench. It's unknown. If bench is not equal to unknown, we'll add that. And then here, we want to get rid of that. I'll stick that there. Okay, so we can do this where we draw the crafting recipes. Recipes are from the blueprint. So we'll put this in here. Where was it? It was in the data downloader menu. Top canvas. No. Description canvas. So rather than just saying the word unlocked, I'll do BP recipes. So that actually needs to be a lot further up. Put it here. So now this should display the recipe in that description box. if the recipe is unlocked. There we go. So let's just quickly unlock a recipe and then we'll call it a day. So, was it data downloader controller? Say that the apple seed is locked. So we'll unlock the apple seed. Nuke Bird, thanks for the follow. If you've got any questions, then please ask. Alright, so let's go transport room 2. And so it's locked. It just says data. We should probably say locked. Okay. Whoops. Just let this rebuild. So it should say locked and then data. Right, that's fine for now. It doesn't look very good, but it doesn't really matter because I'm going to do a complete pass over all this UI stuff. So that's locked. So let's go and charge these data cards. It's a custom UI, yeah. Yeah. Although IamGUI is really good. Yeah, I've done a lot of custom UI, all this stuff. Find something interesting. So, you know, like color pickers and it's quite similar to IamGUI, but I wrote it all myself, yeah. I think GUI, UI is really hard and I wanted to kind of get better at it. So I decided to do it all myself. But yeah, IamGUI is also awesome. I would use that if I was just trying to make some kind of like commercial game engine. But if you want to get better at programming UI, make it yourself. Yeah, all this. Yeah, exactly. I mean, I've been trying to code UI for years. This is like, I've written a few engines and each one's gotten better and better and better. I think UI is one of them systems where you can get really far into it and then realise you've done it all wrong. You know what I mean? So it takes a lot of effort to do it right. There's all sorts of different things that catch you out. Like you might say, all right, well if I want a button, I just detect if the mouse is over this box, and then yeah, that means the button is active. And then you'll implement like a scroll bar. Like maybe like months later, you'll be like, all right, now I'll do a scroll bar, and then you like do it, and then the scroll bar goes off, and then the mouse does go over the button, but it's the scroll bar that's active. So you don't want the button to go active now, even though the original condition was, well, when the mouse goes over the button we make it active. There's loads of like little hidden things like that, which makes it difficult. So then you'll find that like, well, okay, well in my button code I'll be like, if you got the scroll bar active, then don't highlight the button. But then you do something like a combo box, and then the combo box drops over the button, and then also means you don't want to highlight the button because the combo box is in front of it. So it's like, yeah, there's just loads of weird stuff like that. And then like that text box is active, and then like for every single other text box now, if I click on it I have to deactivate that one, you see. And I don't want to write obviously in every text box, like go through all of the text boxes and make sure that none of them are active, or you know, if any of them are active, deactivate it. So there's loads of really hidden things. Yeah, it's absolutely, it's quite mental. Oh yeah, I'd always recommend trying, if you're wanting to just learn, make an engine. And then eventually you get good at it that you know, so good at it that you could make engines for proper projects and you don't need to use Unity and stuff. And it doesn't really take you much extra time because you've got so much knowledge and you've got so much code already written that you can write, you can have a custom engine for a proper game. Yeah, and this UI is obviously different to the editor UI, but another thing that I've written is you can separate the UI into two parts, like the back end stuff that handles all of the input and everything and all of that logic, and the front end stuff which just draws it all. And if you separate them properly, you can, so this, all the back end for this UI is the same code as the editor UI, it's just drawn differently, and that's something you learn as well. ECS or OOP? Well, it's like a loose entity component system, I suppose. It's not a strict ECS, but I do have like this concept of you have an ID, and then the ID can mean lots of different things. You know, the ECS is like you have an entity, which is like usually an ID, and then you have lots of components that have that ID. And then you know that that component belongs to that entity and stuff. It's kind of loose like that. Teslotic. How did you make an animated cursor inside the text field? You mean like the carrot? Do you have a global animation object or propagate reference to that cursor on top of the tree? Like the bit that I share from like the entity component system is the idea that you can share an ID across different systems, So, good example of that is in the world map that I've just kind of started an hour ago. This location's got an ID, and that ID is the same ID as the fast travel node ID, even though they're two separate structures. So I can say like, well, I can get the ID for this location in the world, look in the fast travel system and be like, give me that fast travel node, and it's the same ID. So that's the bit that the cursor inside the text field is just a line, straightforward line. So I'm rendering like all these glyphs, and then there's like a text input structure, and it's got where is the cursor in glyph space. So like 1, 2, 3, 4. It's in the fifth glyph. It's just past the fifth glyph, and then I'm just pulsing a line every second. So it's really straightforward. And then you can select them. So you change the background color and you change the foreground color of the text. C++ 20 ECS live in 2 weeks. Cool, man. Yeah. Yeah, I did look at an ECS library. What's it called? It's very famous. Is it called like Ent? Let's have a look. I mean, I say it's very famous. It's like a big ECS. Used in Minecraft. But it was like 200,000 lines long. And it's like, man, I don't want to import that much code for an entity component system. So I have written entity component systems before. And they're good. Yeah, Ent, yeah. And they're good. I think they have a very rigid structure, and they help you along making something big. But I'm at the stage now, I think, where I'm happy with just having like IDs shared across systems, and the components, like, there's not really this notion of components. I tend to the way I do it is I have all these things called controllers. So everything that ends in a controller is like a big system, I suppose. And they store the IDs, and the IDs refer to, I suppose, the different types of components. They're not really components. Teslotic. Your text field receives update every frame. So you animate cursor in that funky way. Yeah. So it's completely immediate. So and if you've heard of IM GUI, the IM is the immediate, which means that everything's touched at least once a frame. And you draw it there. Well, you don't draw it there, but you actually decide that you're going to render it there. So if everything's touched once a frame, it's easy to do animation because you're doing it every single frame. Yeah, the controllers are the big systems. They're like the public-facing APIs that you can use in other parts of the game to get information. And they usually have arrays of, of the little bits that they need, and the little bits have the ID, and in each controller the ID can be shared across different controllers, so that's how you link them together. You know, like in components, like how do you link all the components together? So one entity is like, the entity is the link point, and that's where it's similar to ECS. But I'm not doing like an ent style create controller, create component, add component to entities, you know, all that. I'm not doing that type of thing. Retained mode. Not sure what retained mode is. Let's have a look. Immediate mode is an alternative. Yeah, okay. That's like .NET. What .NET does. That's also a good way to do it. I don't mind that. I quite like .NET. Yeah, so there's kind of two different types, I suppose. There's like, do you let the backend system manage absolutely everything and just call you through callbacks and events when things happen? And I think that's retained mode. And IAMGUI is like, if you want a button, you just draw it right there. So it'd be like, if draw button, hello, like that. And then this is like the button's been pressed here. Whereas a retain mode thing might be like button on press and then some kind of like callback. So this is like a C++ callback. Both are good. Thing about this is you have to cache this. You have to like keep this in state somewhere, which is fine if you've got very small bits of UI, but if you have lots of big UI, like this first one here, you're not storing anything. And that's the real, I think that's kind of like the appeal of immediate mode. You don't have to store anything. I kind of do a hybrid. So mine is canvas draw button. Hello. Like that. So you do have to store the canvas. But there's only one canvas. As opposed to like, if you had a canvas with like 700 buttons on it, you still only have to store one canvas. But in the retained mode, you would have to store 700 buttons somewhere. And I just do it this way so I can break up kind of like where I draw things. So I have the logical idea is that you create canvases and canvas just occupies an area of the screen. And then you don't have to worry about positioning the button. You just call draw button and it'll draw it in that area of the screen. That's why I have the canvas. So like here, got two areas of the screen, the locations and the map. So this is just a draw button call, but because it's in the locations canvas, it puts it there. And if I was to do draw button in this canvas, it would put it there. That's why I do separate. That's why I have the canvas, so I can create multiple canvases. Yeah, UI is fascinating and very, I think, one of the most difficult it's one of the most difficult programming problems in programming, really. Mainly because there's lots of little hidden things. Right. Int max here. This is so this is to do with where you want to draw it. So these are two draw calls, draw the outline and draw the quad. If you wanted to draw them consecutively, so draw that one first and then that one over the top of it, this has to be the same int value as that or higher. Which means if I did like 2 and 1, it would mean this would get drawn first and then that one would get drawn. But if I do 2, 2, then that one gets drawn first, then that one, or 3 or 4. So by int max, I'm just saying draw it at the very front of the screen. You know, you're drawing things and then drawing things over the top of things. Yeah, like draw priority, yeah. Now it shouldn't be int max. Eventually this will get changed to have a Z order. I'm only put int max for now because I'm just kind of messing with it really. Where was it? So canvas.get Z order, right? And then you can actually get the Z value of particular types of things. So quad, that would be quad. And what that does is it helps the renderer batch everything up. So, and then if it can batch things up, it can draw it all together. So you reduce your draw calls. So eventually we'll swap to doing that. Yeah, exactly. It's all right. Yeah, there's pros and cons to both. Like I say, if you're doing immediate mode GUI, like you're often touching everything all the time. So I wouldn't recommend doing something for like, if you're going to do an operating system and you wanted to run it on really low end PCs, you're better off doing a completely different strategy and completely different rendering strategy. You want to be able to have some kind of tiled renderer where you're just rendering. Like here, for instance, I make that blue. When Visual Studio wants to render it, it's probably only rendering that, and the rest is just fixed in memory, and that makes rendering really, really cheap. The thing with games is you're often clearing the screen every frame anyway. So you may as well go for an immediate mode. Because the benefit of immediate mode, of course, is that it's often a lot simpler. That's why people like IMGUI, because it's really easy to use. But yeah, it's like, do whichever one you want. I'm pretty sure you can call back button clicks. Maybe you can. I don't know if you can call it. On previous UI systems, I've made it so you can cash out a button. Thanks for the follow, Tesla Tick. That's great. Thank you. So the draw, what the draw is doing is it's creating like a draw command and pushing that onto a list of commands. And then when you finish drawing everything, so at the end of the frame, you get the canvas has this big list of things that you wanted to draw. And then it does all of its like sorting and batching. You know, like culling anything that doesn't need to be drawn and stuff like that. And then that gets sent to DirectX layer, so like the back end of the renderer. So the back end of the render is like DirectX or OpenGL or Vulkan or something. And then that gets this list of batches that's been processed. So it doesn't draw here, it just adds the command in. And then, yeah, it gets all sorted out, sent to the back end of the render, and then that actually does the drawing. Yeah, it's like a front and back. So it means you can swap them. If I wanted to do, right now it's DirectX 12, but if I wanted to do a Vulkan renderer, I don't have to alter any of this code. This just stays the same, and I just add on a new backend, which, you know, saves a lot of programming. So if you do draw quad, I'll have to draw quad outlines, a bit more complicated than draw quad. But you can see there, it just creates 4 vertices, builds a quad in there, and then adds the draw item, which is the vertices, the material, the topology, so it's going to be quads, and then the Z, and then that draw item's added into the canvas. It's like only a little bit of data. Yeah, it's I kind of got everything I wanted to get done today. Now. Yeah, so the game's been going for 6 weeks. Not the engine. The engine's about 18 months old. But the game's been going for 6 weeks. So all these are like I'm just doing a bunch of gameplay, prototyping. So that's why the rooms don't look very interesting. But like each room's got something in it. Like that's got a chest. This next room is the shop. And it's like none of the UI is permanent UI. It's just the prototype UI. I'm going to go over in a few months and make a good UI, you know, with proper icons and things. And then this room's about resources and stuff. So Sven's a droid, and he can break rocks apart. So if you break rocks, you get iron ore, and then you can destroy grass. Gets carbon for grass. And then what else can he do? You can plant seeds. And then you can fertilize seeds. So it's going to be like a sci-fi gardening game. So you do all your gardening with like a droid. And you're on a space station. You don't look very space station-y, but you will be on a space station when I start drawing it. The paper for skeletal animation. The animation I use is really awesome. Piece of software. Is this? So it's third party, the animation. And it is skeletal animation, yeah. So the character that I've got is just one of their characters. I haven't drawn, like, there's no real art for the game drawn yet. Like, the bits of art that I have, apart from that character I drew like for a previous project. But I'm pretty sure the skeletal animation's very, it's similar to 3D. So the main bulk of the animation is from Spine, that software. So it's a third-party library called Spine, and I didn't write this. So that does a lot of it. But then I have my own animation. There's several types of animation in the engine. So the skeletal stuff, most of it's Spine. But then I have also added on different bits. So this animation routine thing. So the idea behind this is it kind of like abstracts the animation away a bit. So all you do is you like define these routines, and the routines are like, what do you want the character to do? So, you know, I want him to walk over and make a cup of tea. That would be a routine, and it's made up of lots of animations that you've authored in Spine, and it like bulks them all together and it sends events, and you can interrupt the routines and stuff like that. So it's like a hybrid, but the actual, you know, the skeletal maths stuff is part of Spine. Yeah, I recommend anyone have a look at Spine. It isn't just C++, they do these libraries for all sorts of different languages. You can use it with Unity and Unreal and stuff. But then there's other types of animation in the engine as well. So there's like framed animation, there's procedural animation, all sorts. Like manual animation, where I'm doing things actually in code. So like that animations I made, that's just in a shader with that thing coming down. The trees are all procedural. So the leaves actually, it's difficult to see on the stream. The leaves, like, they like blow around in the wind, see? That's procedural. And then there's framed animation, so if I a good example of framed animation is the rain. If I go to a level that has rain, so the rain here, that's like a framed animation. So I made that in After Effects. It's like a video I made in After Effects, and the engine imports it and compresses it, and then can use it. Then all the clouds and stuff are procedural. But yeah, it's good. So yeah, what I'm kind of doing at the moment is just doing loads of gameplay. So I've been working the last couple of days on fast travel, which are these pink squares. They're only debug things, so I just know where to go. And there's this kind of bookcase in the middle of it because I was doing like a light effect, so like the light shines on through the bookcase. I don't know if you can see that. It goes quite fast. I'll go back. If you look out for the bottom of the bookcase, see it like shines through. So I was working on that so you could put things in front of the fast travel effect and it would kind of cast God rays out. And then I was working on the world, like beginning of the world map, because I want to be able to like click things to fast travel to them. It's more intuitive, I think, if it's in the map rather than just a list of locations that you have to remember. And then like the NPCs can use these. These are like Star Trek beam, like where it says beam me up type things. So like the other NPCs can use them. So he's coming in. So I put that in yesterday. And he walks through the table because there's no collision on the table. And this white dot is a quest, like a quest marker of where to go to complete a quest. Yeah, got cutscenes and stuff. It's good. Anyway, I'm gonna have to head off because I have to go and get my kid from school. But I stream every Monday to Thursday from 9:30 in the morning GMT till usually around 3 o'clock. So I'm on almost every day, every weekday. But yeah, the game's been going for 6 weeks, so it's at the beginning. So in a year or two, it should look a lot different. Check all this stuff in. But yeah, it was nice talking to you. Hopefully see you around. I'm gonna sign off, so I'll see you later. Pick my kid up. See you later.